taking derivatives with limits can be very, very tedious and time consuming. So over time, mathematicians have developed these tricks that help make derivatives much quicker. So we're going to take a look at one of those rules today. That is the power rule of derivatives. So I've written it down here, and this piece, d dx, means take the derivative and with respect to x, and here's our function, a x to the n. That equals a times n, x to the n minus 1. So this equation, now I could write this y equals 3x squared, but I'm going to take this derivative. So d dx of 3x squared is going to equal, let's use the rule. So it looks like I take the exponent and multiply it times the coefficient in front. So 2 times 3 is 6. And then if I look at this portion, it looks like I decrease my exponent by 1. So 1 less than 2 is 1. So there's my answer. That is my derivative. So f prime of x is going to be 6x. And then if I wanted to evaluate, say, I wanted f prime of 7, I could put a 7 in here and get 42. Now this one has a whole list of different things. It's a polynomial. And another rule of derivatives is going to be that I could do each of these terms separately. So I can do this term, then this term, then this term, then this term, and combine them all and get my final derivative. So I'm going to do the derivative with respect to x of this, and I'm just choosing to use this different notation now because it's going to be helpful here later, so we're going to get used to it. So that's going to equal, let's apply our derivative. So 4 times 3 is 12. Decrease this exponent by 1. Negative 5 times 2 is 10. Decrease that exponent by 1. And there is an implied 1 right here. So 6 times 1 is 6. And then if I decrease that exponent by 1, 1 minus 1 is 0. And then now this, I'm going to show it. This would be like x to the 0. And 7 times 0 is 0. So that's just 0. And that should make sense. The derivative of any constant is 0. Now this x to the 0 is simply 1. So my f prime of x, my derivative is 12x squared minus 10x plus 6, because this would be a 1. And there is my final answer for that one. So hopefully you're thinking that's pretty easy, but let's take a look at some more challenging questions. So f of x is going to equal square root of x. Now, I need to write that in exponential form. And that is going to be the case for any time I have roots. I'm going to write them with exponents. So a half is the equivalent of a square root. So now I'm going to apply my rule. So I'm going to take the derivative of this, and that's going to equal 1/2. So I have a 1 up here, so I'm going to multiply a half times 1 is a half, and I'm going to decrease my exponent by 1. So a half minus 1. Well, how do I do that? That's going to be a half minus, get a common denominator, 2 over 2, so negative a half. Now, I'm going to want to simplify this if possible. So I'm going to actually move that down to the denominator, and the exponent will become positive. And then I'm going to remember that a half is simply a square root when it's an exponent. So this is my derivative right here. Yes, this is the answer, but we want it in simplest terms. And we are going to not rationalize for these things. We are not going to rationalize. We're just going to leave it like that. That is fine. Okay, so let's take a look at this. So I'm going to rewrite this, and I'm going to get x to the 1/3. Now, in case you forgot, let's say I have a root, and let's say I have x with an a right here and my index is a b, an exponential form that is x to the a over b. Okay, so I've done that. Now I'm going to find my derivative. And to do that, I'm going to multiply. So I'm going to multiply those. So that's going to be 4/3. And then I'm going to decrease this exponent by 1. So that would be 1/3 minus 1, which is 1/3 minus 3 over 3, which is negative 2/3. So this is negative 2/3. And while technically that is the answer, I'm going to want to write that with radicals if possible. So remember, I can move an exponent down into the denominator, and if I do, it becomes positive exponent. And that's going to give me 4/3, and this is going to be the third root of x squared. And there's my answer right there. Now, hopefully you followed along with that, but if not, I used a lot of different rules right there that I'd be happy to explain later. All right, here's a quotient. Now, there is another way to do a quotient than what I'm going to show right now, but we are going to use the power rule only, which means I'm going to have to move this x actually up into my numerator. So I'm going to have 3, and when I move it up, I'm going to get x to the negative 1. So I'm using this this rule of exponents, where if I had x to the negative a, I could move that down and get x to the a. And if I had x to the a, I could move that down and get 1 over x to the negative a. And those would switch. So that's how we actually evaluate something like 4 to the negative 2. Some students erroneously would say, oh, that's negative 16. And that is false. That is not negative 16. It means 1 over 4 squared, which is 1 over 16. Okay, so anyways, back to this. Now we are ready to apply our power rule. So we're going to get negative 3x. Now I'm decreasing this exponent by 1. Well, negative 1 minus 1 is negative 2. So I have a negative 2 right there. So I'm going to have negative 3 over x squared. And that is going to be my derivative. That is my f prime of x. Okay, now this one is going to be fairly complicated. And again, there is another way to do this one, but we are doing the power rule. So I need to write it like a power rule. There's too much stuff here. That's the key. If there's too many x's, you need to get it all down to 1x. And like if we go back to all of these, notice this example only had 1x involved, only 1x involved. If I go back to this example, this was a polynomial, but each term only had one thing of x. So that's very, very important that we don't have something that is too complicated for these. So I'm going to go ahead and move this piece up. And when I do, and I'm going to want to remember it's x to the 4/3 when I switch it to exponential. So when I move it up, I'm going to have x to the negative 4/3. And now I'm going to have to actually multiply that. So when I multiply it, I need to remember that if I had x to the a times x to the b, I can add my exponents and get x to the a plus b. So I need to do 2 plus negative 4/3. So I'm going to change this to a fraction with a common denominator of 3. So it's 6. And this was a negative 4/3. So I get I get 2/3 when I combine those. So this equals 5x to the 2/3. Now I am ready to go ahead and find my derivative. So d dx, the derivative with respect to x of this, is going to equal, I'm going to multiply those, so I get 10/3. And now I'm going to decrease that by 1, which is going to give me negative 1/3. I'm going to move that down to my denominator, and I'm going to get a final answer. F prime of x is going to equal 10 over cube root of x when I switch it back. Before going on to the last thing, I just want to do one more example of that just to make sure that we are good. So let's say I had f of x equals, say, 2x to the third. I'm going to do actually two more examples. X minus 7. Let's do this one, and let's also do, let's keep that cube, and let's do a square root of x to the 7 there. We don't need it that complicated. Let's do a 3. Okay. Yeah, that could be simplified, but we won't. Okay, so this one. So this has too many different pieces. See, I have a thing times a thing. So this is not a polynomial, but I could make it a polynomial if I distribute this. And I would get 8x to the 4th minus 14x cubed. Now I can find my derivative. So if I wanted to find my derivative, I would not do this. Again, too much stuff. I need to simplify it out, multiply it out. I mean, there is a way to do it from this step, but this is by far easier, and we'll get to that later. So now I'm going to apply my power rule of derivatives. So I get 32x, decrease that by 1 there, minus 3 times 14, 42, x, decrease that by 1, 2. Okay, so there's my derivative. All right, so this one, I'm going to need to move this piece up. And when I do, I have x to the 2/3. When I move it up, I'm going to have 2/5 x cubed times x to the negative 2/3. So I need to get a common denominator there, and that would be 9/3 minus 2/3, which is going to give me 7/3. So I'm going to have 2/5 x cubed. I shouldn't be writing all these equal signs, but I'm showing all the steps here. When I combine those, 7/3. Okay, so at this step, I am ready to take my derivative. So my derivative of this, I'm going to multiply those so you can get all these fractional things. So 14 over 15x. Now I'm going to decrease that by 1. When I do, I get 4/3, and I can write that as, I'll just write it in the numerator, the cube root of x to the 4th. So hopefully, compared to using limits, you're finding this much simpler, but there are little tricks that you're going to need to do in order to make it work out. So let's take a look at this last slide. I've set it up. Now, we're actually not going to answer any one of these. I just want to point out that we actually, with what we have just done, just using what we just done, we cannot do this. It would be wrong to make this, you can't distribute this. You can't write it as this and then distribute the exponent. That's wrong. You can't do that. So in essence, what I'm telling you is that this thing is too complicated right now. We're going to have a different way that we can approach this, but with what we have just right now, we actually can't find this derivative. So if we were asked to do it, we would actually have to revert back to using limits. So whenever you don't have enough, if you don't know the trick, or you can't do it, you have to revert back to that definition of limit, or definition of derivative, and use limits. And the same thing is true here. Like, this is too complicated. Now, I could move it up, and I would get, and this might actually be a step I would do. I could move it up, and I'd have x plus 5 to the negative 1/2. But this stuff here is too complicated. You might think, well, how is that too complicated? It's just x plus 5. Well, it's because it's more than just an x. And if you take a look at it, now I'll change it so I can do it. And this will actually lead us into what's coming up. I could change this. And I could do 3u to the negative 1/2 I could actually do that because that's very similar to if I had 3x to the negative 1/2, and let's go ahead and do that. I can find this derivative. So the derivative of that is going to be negative 3/2 x, decrease that by 1. So a negative 1/2 minus 1, that's minus negative 2/2 is negative 3/2. And then I could simplify that. So that's going to be negative 3/2. And then move that down, the square root of x cubed, and we could just leave that like that, that's fine. There's our derivative. And if I found the derivative of this piece, it would be this. But that is not the answer to, I can't just put, it's not as simple as just putting this x plus 5 back in. So it is not, and this is not the answer. Not the answer. But we're just setting this up for a discussion later. This, though, this is the correct next step to actually find this derivative, but we'll get there later.